Hello there. Today we're going to look at value objects. My name is Waidera from Kodarasa. Some objects will have no conceptual identity, unlike what we saw when it came to entities. They describe some characteristic of a thing. What exactly is a value object in this case? This is an object with a descriptive aspect of another domain object. In this case, it will be an entity, a value object. It has a descriptive aspect of a domain. Whether or not something is a value object or not is dependent, as it happens for many things in computer science. Let's look at an exam sheet. For example, we are sticking with the school management system genre theme. So if I have my exam sheets, before I give them to my students, at this point, as an instructor, as a teacher, I'm not concerned whether I give you the first copy or the 20th copy. They're all the same. They're all interchangeable at this point. If a student makes a mistake within a few minutes into the exam, I can still give them another extra copy so that they use that and we discard the previous one. So in this case, at that point, it doesn't matter which copy you have. They're all the same. They're very interchangeable, and that's how value objects operate. We don't care about the identity. But then it's different after the students have done their papers. We now need to grade them. It's very essential that we need to know whose paper belongs to who. At this point, we care about the identity. In this case, who does this paper belong to? What are they scoring? So in this case, it has moved from being a value object and now maybe it can be classified as something different, like an entity. Examples of value objects, we can find them in different forms. They are an assemblage of other objects. Looking at the example here, we have timestamp, which is an assemblage of nanos and seconds. We have date time, year, month, yada, 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 everything pertaining a date time. We can also see we have an address. You can have different types of addresses depending on how you want them, depending on even the country you're in. For instance, in my country, a common address would have a postal number, would have a town, let's say Modara, would have a postal code. All these are what now makes up an address. You can even have a street number, depending on the application you're modeling for. But again, you can see it is describing specific thing. It's describing a value. It's describing an address in this case, and everything that makes up an address goes into the value object. Another way to look at value objects is that they are attributes of entities and other value objects. Looking at an example here, we have a student entity with ID 12 named Karendi. We have class 1 name and created that, which is an attribute of student, that is they created that time, but points to the value object, which is nanos and seconds, an assemblage of that. So in this case, timestamp is now an attribute of another domain object, which is entity, but it can also be an attribute of another value object. It's not restricted to entities. We can also find value objects, often passed as parameters, in messages between objects, and last but not least, we find them as references to entities. Attributes that make up a value object should form a conceptual whole. One thing you really need to be keen about, if you can do as much as possible to make sure it fits within this constraint, is that you should always have them as immutable. Some languages will not have these provided for you, provisioned for you easily, but if as much as possible try to model your value objects in a way that they are immutable and they're not easily going to be changed within the course of their life cycle. You can also only change value objects with full placement. The moment you make a slight change, whether it's in part or in whole, then it becomes a whole different value object. We measure equality when it comes to value objects by virtue of all the attributes being equal to. So two value objects are equal if all the attributes are the same as all the attributes for the other one. So that's how you measure equality, and like entities where you maybe now look at ideas to check for equality. So in this case, if you're going to change it, it's a full placement. You can't change parts of it, and at that point it also becomes another value object. And last but not least, we've seen that value objects should never have identities, and it's not just a matter of laws, but it can be, imagine a case where we're tracking all the timestamps you have in your system that have happened, tracking that, giving them identities. For one, it is very unnecessary. It can be very expensive. why are you doing that in the first place? So that's something you should never do. Let's design a value object. When designing, we should not care what instance we have of a value object. We've seen we can interchange. Going back to the exam sheet paper, if I give you a different paper before I need to grade your papers, then it doesn't matter to me. They are all the same because they are all copies of the same thing. How do we optimize performance when it comes to value objects? We can do this one by copying. We've seen, for instance, in the exam sheet, we had different copies of the same paper. We can also do so by sharing, where I give you the copy of what I have or a reference to what I have so that you can be using it anytime you need. So that's a really good way to optimize performance when using value objects. And last but not least, I cannot insist this enough, try to use immutability as much as possible. So when do you use copy? When do you use share? To be cliche, it does depend. And what does it depend on? It depends on the implementation environment. So let's look at it. Let's say we have copies. Every time you need something, you make a copy of it. Every time you need something, you make a copy of it. Then you will end up with a scenario where you've clogged up your database with a lot of copies of something, or or many copies of different things. In this case, then, if you are limited when it comes to space, then it's an issue for you. Let's now look at sharing. Imagine a case where we have a distributed system, and every time I need to share something with you, so I send a message to you, maybe a reference to where it is contained, and then every time you have to make a call into my system to get it, then it becomes a lot of overhead when it comes to distributed systems. So these are some of the things you need to look at when determining whether to use copy or share. For instance, when you use copy, that copy will live in that system. So in a distributed system, this is totally perfect because you don't need to do that lag, that waiting for the response from the other system. You have your own copy, you can easily now fetch it internally. Like, it's more centralized in this case, it is in your system. When it comes to sharing, you just have reference to it. So for each call, for each interaction, you have to make a call to the other system, which can delay. So when do you use sharing? Only use it when it is most valuable and when it is least troublesome. Consider it when trying to save space. You've seen why this is the case. If you have an issue with space, then as much as possible, having many copies of something will clog up your system and you'll have an issue with space. You can also consider using sharing when your communication overhead is low. Let's look at a centralized system, e.g. a monolith. Everything is contained in the same place, so you don't have a scenario where you now have to get content from someone else from a different machine. Then you don't have a lot of wait times, and it's not going to cause any issues in terms of performance. Then you can use sharing in this case because it's easy to fetch. And last but not least, when using sharing, try to insist on having it be immutable, because imagine a case where I am sharing a resource with you and I've given you a reference to how to find it. Then I find the next time that I need to use it, that you've changed it to something else. Then I have a case, I've corrupted my data. For one. I'm dealing with what I don't need. I can even crash my system. I'll have many issues because something was changed that you expected to be one thing, but it's not. So when sharing, it's it's even more essential to now have immutability. And that's it on value objects. Thank you. My name is Waithera. Bye.